Okay, I don't want to spend as long on these ones, but I am going to walk you through how you are meant to do them. So with this one, you're just coming up with all the possibilities. So think about, I can have tails and heads, and then what can I have for these ones? It's always going to be tails and heads. You just need to come up with all the possibilities for it. Okay? Then you're going to use that table to figure out how many possibilities have two tails and a head in any order. Okay, so I'm not going to go through that. This one, once you figure out what the pattern is, so what they're doing is they're multiplying the first die by the second die. Okay, so you're going to fill in all the scores that you could possibly have. So we've got 1, 2, 3, 4, 5, 6, okay, 2, 4, 6, 8, so on and so forth, all the way down. Okay, then it wants you to find the table, the probability of scoring 12, scoring more than 15. Okay, so again, you're just using the table to find out what the probability is. Skipping ratios. Skipping ratios. Skipping ratios. Now, apparently I have a lot of ratio questions in here. There we go. Dependent events. Now, dependent events means that based on what happens in the first one, it will affect the second one. Now, generally that means I've taken one out of my sample size, so my denominator has to become smaller. So, if we look at this question here. So, first of all, you have to be able to identify what the important information is. So, I know that we have, 10 bulbs, okay? Now, 7 of the bulbs will produce pink flowers, 3 will produce blue flowers. Now, if I take a bulb at random and plant a second bulb, I want to calculate the probability that the 2 bulbs will produce at least 1 blue flower, okay? So, my important information, I know that I have 7 out of 10 that give me pink, and 3 out of 10 that give me blue. And I know that I want at least 1 blue flower. So I have a couple different scenarios. I can pick 1 blue, 1 pink. I can pick 1 blue, 1 blue. And I can pick 1 pink, 1 blue. So those are my 3 options that are going to give me 1 blue flower at least, okay? So now I want to find the probabilities for each of those. So what I want to do is I want to find the probability of getting 1 blue flower, so I know that's going to be 3 over 10, okay? And I want to multiply that by the chance of getting a pink flower out of my second one. So that's going to be out of 9, because I'm taking away 1 of those flowers, but I still have 7 of the pink bulbs, okay? So that's my first one. 3 over 10 times 7 over 9. Next one is blue and blue. So that's going to be 3 over 10 still, times, now I've taken away 1 of those blue bulbs, so now I only have 2 blue bulbs out of 9. Okay? And then the last one, I've got 7 out of 10. So I know that's my probability for pink, times 3 over 9, because I've got 3 of those bulbs that are blue out of the 9 left. Now, each one of these I'm going to add now to each other, and that's going to tell me what my final value is going to be. So for this one, I'm going to get 21 over 90 plus 6 over 90 plus 21 over 90. Okay? Which gives me a final answer of 48 over 90. Now, if I look at this fraction, can it be simplified? Yes, it can. So remember, when you're simplifying fractions, easiest way to do it is just divide by 2 and then see if you can divide by 2 again. So that gives me 24 over 45. And if I look at that, 24 and 45 are both divisible by 3. Which leaves me with 8 over 15, which is my final probability. Okay? So again, I found out what my chances are that all my outcomes that are going to fit that scenario that I'd like. I found the probabilities of each one of those, I multiplied them, and then I added them all together. That gave me my final answer. Let's look at this one. So this one, we have 20 students in a class, 14 are girls, 2 students are randomly selected from the class. What is the probability that a boy and a girl are chosen? So for this one, we have 2 different outcomes. We can have 1 boy and 1 girl, or we can have 1 girl and 1 boy. So a little bit less complicated. So we know that 14 out of 20 are girls, which means that 6 out of the 20 are going to be boys. So my boy is going to be 6 out of 20 times my girl. Remember, I've taken 1 out, so it's over 19 now. And I have 14 girls. Okay? And I'm going to add that to 14 out of 20 times 6 out of 19. So basically, I have equivalent scenarios. So I end up with 84 out of 380 for each one of these. Oops. There we go. Which leaves me with 168 over 380. Again, I can divide that by 2 and divide it by 2 again, but I'm just going to divide it by 4. And I end up with my simplified fraction of 42 over 95. So 42, 42 out of 95. Beautiful writing going on right here. Okay, lovely. Okay, so tree diagrams. We love tree diagrams. Now, when we come to tree diagrams, it's all about being able to pick out the information and know where it goes on the diagram. So, we know that he is hitting a straight drive on 80% of the occasions when the weather is not windy, but only 30% when it's windy. So I know on a not windy straight drive, he gets 80%, but when it's windy, only 30%. And we suggest, the local records suggest the weather is windy 55% of the days. So that's the first one we want to do, is that windy 55% of the days. So when it comes to the weather, we know 55% of the days the weather's windy. Now, I want to represent 100% of those days. So, if I know 55% of the days are windy, that means 100 minus 55 gives us 45% of the days are not windy. Now, they've already filled in that he hits 80% of his straight drive when the weather is not windy. That means that the other 20% is going to be not straight drives, okay? Because I can either have a straight drive or a not straight drive. So that 20% is that not straight drive, okay? So again, we want each one of these to equal 100. Now, when it's windy and he's hitting a straight drive, he only hits it 30% of the time. So again, I want the 2 ones to add up to 100, which means that he's hitting 70% on his not straight drives. Okay? So, once we've done that, we want to find the probability that the golfer hits a straight drive. Now, to do that, I need to find the probability when he's got a windy and when he's got a non-windy. So, what we want to do is we want to take the probability that it's going to be either windy or not windy, and then the probability that he's going to hit his straight drive. Okay? So if I take a look, I'm going to start with the windy, or sorry, not windy. So it does better that day. So if it's windy and straight drive, I get 0.45, which is just 45% as a decimal, times 0.8, okay, which gives me an answer of 0.36. Okay, then I want, oh sorry, this was not windy. Then I want windy and straight, okay, which gives me 0.55 times 0.3, which gives me an answer of 0.165. Now, what I'm going to do with those two is I'm going to add them, so that gives me 0.36 plus 165. Not doing a very good job with writing today. Okay, which leaves me with an answer of 0.525. Okay, so that is our dependent probability. Okay, I'm going to do another video on independent probability because I'm almost out of time on this one. Alright.